Stepper motor is a brushless DC motor that rotates in steps. This is very useful because it can be precisely positioned without any feedback sensor, which represents an open-loop controller. The stepper motor consists of a rotor that is generally a permanent magnet, and it is surrounded by the windings of the stator. As we activate the windings step by step in a particular order and let current flow through them, they will magnetize the stator and make electromagnetic poles, respectively, that will cause propulsion to the motor. So that's the basic working principle of a stepper motor. There are several different ways of driving the stepper motor. The first one is the wave drive or single coil excitation. In this mode we activate just one coil at a time, which means that for this example of motor with 4 coils, the rotor will make full cycle in 4 steps. Next is the full step drive mode, which provides much higher torque output because we always have 2 active coils at a given time. However, this doesn't improve the resolution of the stepper, and again the rotor will make a full cycle in 4 steps. For increasing the resolution of the stepper, we use the half-step drive mode. This mode is actually a combination of the previous 2 modes. Here we have 1 active coil followed by 2 active coils, and then again 1 active coil followed by 2 active coils, and so on. So with this mode we get double the resolution with the same construction. Now the rotor will make full cycle in 8 steps. However, the most common method of controlling stepper motors nowadays is the microstepping. In this mode we provide variable controlled current to the coils in a form of sine wave. This will provide smooth motion of the rotor, decrease the stress of the parts, and increase the accuracy of the stepper motor. Another way of increasing the resolution of the stepper motor is by increasing the numbers of the poles of the rotor or the numbers of the poles of the stator. By construction, there are 3 different types of stepper motors: permanent magnet stepper, variable reluctance stepper, and hybrid synchronized stepper motor. The permanent magnet stepper has a permanent magnet rotor which is driven by the stator's windings. They create opposite polarity poles compared to the poles of the rotor, which propels the rotor. The next type, the variable reluctance stepper motor, uses a non-magnetized soft iron rotor. The rotor have teeth that are offset from the stator, and as we activate the windings in a particular order, the rotor moves respectively so that it has minimum gap between the stator and the teeth of the rotor. The hybrid synchronous motor is a combination of the previous 2 steppers. It has permanent magnet tooth rotor and also a tooth stator. The rotor has 2 sections which are opposite in polarity, and their teeth are offset as shown here. This is the front view of a commonly used hybrid stepper motor, which has 8 poles on the stator that are activated by 2 windings, A and B. So if we activate the winding A, we will magnetize 4 poles, which 2 of them will have south polarity and 2 of them north polarity. We can see that in such a way the rotor's teeth are aligned with the teeth of the poles A and unaligned with the teeth of the poles B. This means that in the next step, when we will turn off the A poles and activate the B poles, the rotor will move counterclockwise and its teeth will align with the teeth of the B poles. If we keep activating the poles in a particular order, the rotor will move continuously. Here we can also use different driving modes like the wave drive, full step drive, half step drive, and micro stepping for even further increasing of the resolution of the stepper. Thanks for watching, and for more visit my official website howtomechatronics.com.